So this is another no calculator section. We're going to do matrices and systems of linear equations. And then by the end of today, you'll be able to solve an augmented matrix using elementary row operations, and you'll actually know what those are, because right now we don't. So what is a matrix, and what are they used for? So you guys have probably heard of the movie The Matrix, but have you seen a matrix? Do you know what it looks like? Okay, so how would you describe what a matrix is? I did draw one on the board. Okay, so a matrix is going to have brackets, and it will have numbers in those brackets. Okay, I'll give you a little sneak peek of one. Okay, so this is going to be a matrix. Okay, this is going to be a matrix. Okay, so a matrix is just a rectangular array of numbers, and they are used to organize information into categories, and those categories are going to correspond to rows and columns of the matrix. So matrices the matrices we are going to deal with are going to be smaller, okay? But if you're doing cybersecurity or coding, what you can use matrices for is to lock a system, okay? And then in order to break a firewall, you'd have to solve a matrix. Obviously, the matrix we're dealing with are going to be smaller, but you can create really large matrices that would be difficult to solve, okay? So difficult to break into, okay? Matrices are also used to just organize regular information. It just presents it in a way that's very quick and easy on the eye. So if you do a lot of reading, right, it's a lot easier to read certain types of information. So here's an example. If you are a scientist studying a population of endangered whales, you might organize your findings into a matrix. So the different types of whales are your rows, and then the male and the female are your rows, and then the different types would be your columns. Okay, so that's a way to present your findings in something that's easily readable. Okay, now the augmented matrix is formed when we represent a linear system with a matrix. So we can use what we learned yesterday and apply those rules to the augmented matrices. So yesterday you guys learned how to solve linear systems. A matrix is a linear system. Okay? It's just organized in a different way, which I personally like better. So here's a linear system. This would be a linear system that we solved yesterday. And then this would be the augmented matrix. So can anybody explain to me how this linear system got translated into the matrix? How would you tell somebody how to make it? Yeah.
Looks like they just took the coefficients from the variables.
Good. So you would take the coefficients here, so 2 and -1, and then this last column is going to be what it's equal to. Okay, so these are our coefficients of x, coefficients of y, and then that would be what it's equal to for the augmented matrix. All right, so then what I want you to do is create the augmented matrix. Oh, sorry. Oh, my bad. We'll do this first. All right, so the definition of a matrix. The way that matrices are called is by their dimension. So their dimension is an m by n. So this is an m by n matrix. And that means that you're going to have m rows and n columns. Okay? And then like I said, that's going to be the dimension. Okay? So if you look at these little numbers, see how this says it looks like A11. It's actually A11. This is A21, A31. And then all the way down to AM1, whatever your M is. This is A1213. So we say that those entries are in the form of A sub ij, where I is the row and then J is the column. So A11 represents the term in the first row and the first column, right? What would A22 represent? Second row, second column. So the term in the second row, second column. Okay? All right, so let's just recap some of the things we just learned. So we learned that the dimension is m by n. So this is underneath your information box. So your dimension is m by n, which represents the rows and the columns. Okay, and then your terms are ij, where I is the row and j is the column. Okay, and then we're just going to write out what these two terms mean. So if you see A11, that's the term in the first row, first column. Okay, and then I want you to write what the second one is, which is A23. Okay, so then, Colin, what'd you put for this?
Second row, third column.
Good. Okay, so second row, third column. Do you guys have any questions about that format? All right. So on the next sheet, it says, "What are the dimensions of the following matrices?" Okay, so you're given a matrix, and then you have to write what the dimensions are at the side. If you know how to do that, go ahead and do so now. Remember that the dimensions are m by n, which are the rows by the columns. Okay, so the first thing we want to do is identify how many rows there are. All right, so Cheyenne, in the first one, how many rows do we have? 2, right? Okay, so this is the first row, this is the second row. So this is going to be a 2 by, and then Yusuf, how many columns do I have? 3, so it'll be a 2 by 3. Okay, and then Vangai, what do you think the second one is? Uh-huh. Yep, so it's going to be a 1 by 4 because there is one row and there are 1, 2, 3, 4 columns. Okay, do you guys have questions about that? Okay, so we can write a system of linear equations as a matrix called the augmented matrix, which is what we just talked about. And then we can do that by writing in the coefficients and the constants that appear in the equations. So what I want you to do is write the linear system in an augmented matrix. Now when you're doing this with a matrix, you have to have your brackets. Okay, so you have to have your brackets for an augmented matrix. Okay, so I want you to go ahead and create that. So based on the example we saw on the first page, I want you to create this one here. Okay, so Dylan, will you read me what your first row is of your matrix?
3, -2, 1, 5.
Good. Okay, and then Josh, what'd you get for your second row?
1, 3, -1.
Good. Now notice how when I'm doing these, I'm lining them up. Okay, as we start working with these, sometimes it's easy to get sloppy, but it really is going to be helpful if you try to keep your columns organized. And then, Michaela, what was your last row? Good. So then that brings us to our next question. If there's no variable, what do you put in the augmented matrix? So what did we put when there was no variable?
0.
A 0. So a 0 goes in place of a missing variable. Okay, and now the fun's gonna start. So before we can have the fun of transforming these matrices, we have to know the rules of the game. And the rules of the game are the elementary row operations. So we can use elementary row operations with the matrices, since performing any of these operations on the augmented matrix of a system does not change its solution. Basically, the elementary row operations are going to be the same operations you can do with any linear equation. Okay, so what we're going to do is we're going to read over these and then we're going to translate them in our own words. So go ahead and read them to yourself real quick, because I'm going to go in a different order. Okay, so we're going to actually start with number 2. So multiply a row by a non-zero constant. What does that mean?
1.
Okay, so you can multiply by 1. Basically, you can multiply by any number except for what?
0.
Except for 0. So let's think about why that works. So you can multiply by any number besides 0. So if you were solving a linear equation, could you just multiply both sides by 0? No, you wouldn't want to, right? If you had an equation, 2x equals 10, right? Something simple. If you multiply both sides by 0, what would you get? 0 equals 0. And remember, when 0 equals 0, that means there are an infinite amount of solutions. There are not an infinite amount of solutions for that equation, right? Could I multiply both sides by 1/2? Yeah, okay, so as long as I'm multiplying by something that is non-zero, that's allowed. Okay, now the top says add a multiple of one row to another. That's actually exactly what we did yesterday. So you guys can see this on the board. Do you guys see the system I have on the board from yesterday? The x plus 2y equals 5, and then I had the 2x minus y equals 15. So if I wanted to cancel out the x's, what would I multiply by? -2. And then after I do that, what would I do with my two equations? Add them together. That's exactly what this is. When it says add a multiple, what's a multiple? Why is 6 a multiple of 2? Because you can multiply something by 2 to get to 6, right? Okay, so when you add a multiple of one row to another, what you're doing is you're multiplying. Okay, you're going to multiply a row by a non-zero constant. So that's why I wanted to do the second one first. So you're multiplying a row by a non-zero constant. And add to another row. Okay, so you're multiplying a row by a non-zero constant, and then you're going to add that to another row. Okay, that multiple. And then the last one, interchange two rows. So to interchange means you're doing what? If I wanted to interchange Henrik and Cheyenne's seats, what would happen? Yeah, you'd switch places, right? Okay, so this would be you're switching the placement of rows. Okay, so all of those are allowed. Okay, and then before we talk about what our goals are, so how we're going to use these to get what we want, I'm going to teach you some notation about how we're going to use the elementary row operations. So basically what's going to happen is you have one matrix, which represents the original system of equations. So we're going to call this the OG matrix. And then we're going to get to a new matrix. Okay, and to do that, we're going to multiply row 1 by 3. And this is how we're going to label that. So you have to do the arrow, okay, and then your symbol is going to be 3 times row 1. All right, and then the next one, we're going to switch row 1 and row 2. So we have our original, we're going to our new, and then on our line, we write R1 and R2 are going to switch. So we have a double-sided arrow there. Some of you think you can do the third one? Okay, so we have our original. We're going to our new. So we're going to add row 1 and row 2 together, and then we're going to put that result in row 2. So we're going to add them together, and then we're going to put the result in row 2. So when you're replacing a row, you have to let me know which one you're replacing it with, because technically you could put it in any row that you want to. The reason why we don't do that with this one is because if you're multiplying row 1 by 3, that's just going in row 1. And if you're interchanging those two rows, you're just switching their place. Okay? It's for ones like these where you have to tell me where it's going to go. All right, so then the last one says you're going to multiply row 2 by 2, and then you're going to add that to row 3, and then you're going to put the result in row 2. Think you got that one? Give it a try. Or if you're unsure, just break it down. So if you're multiplying row 2 by 2, what does that look like? 2R2. And then you're going to add it to row 3. and then you're going to put the result in row 2. Okay, so this is going to be the notation that we're going to use as we go from one step to another. And these were just some examples of things that you can do. Okay, you're going to be able to choose. You're going to be able to choose what steps you want to take in order to solve. Right, so in example 1, which we're going to do in just a second, we're going to solve a system of linear equations using an augmented matrix and our elementary row operations. Okay, so these were the key things that we said we were going to learn by the end of today. Before we get started, let's talk about what our ultimate goal is. And it's actually going to be similar to the goal that we had yesterday. So remember yesterday we talked about strategy 1. And what was strategy 1 from yesterday? What was one strategy that we used to solve our systems? Yeah, we put it in triangular form. So we were putting it in triangular form because we wanted to have an x, a y, and a z, and then a y and a z, and then a z, because if we could put the system in triangular form, what could we use to solve? What is that called? What did we use to solve yesterday? Back substitution. Okay, so that's what we're going to do today. We're just going to do it with matrices. Okay, so our goal is to eliminate the x term from the second equation and the x and the y terms from the third equation. Isn't that our exact steps from strategy 1 from yesterday? For step 1, it was eliminate x from the second equation. And then step 2 was eliminate x from the third equation. Step 3 was eliminate y from the third equation. Does that ring some bells?
Yes.
Are you guys alive?
No.
No. All right, and then, well, why are we doing this? So this is going to create a system in which we can use back substitution to solve. Okay, so our main goal is to be able to use back substitution. So let's think about what our matrix will look like if we reach our goal. So if we want to eliminate the x term from the second equation and the x and the y terms from the third equation, let's think about what our matrix is going to look like. Okay, in the first row, do I have an x and a y and a z? Yes, I have everything. So you are going to want a 1 right here for your x. And then the rest of them can be filled with any number. So x, y, z, your constant term. Okay, so that's going to give you an equation where you have x plus some y plus some z equals some number. Okay, now in the second equation, what variable do we not want? We don't want x. So if we don't want a variable there, what do we put in its place? 0. So we're going to have a 0 for x. Okay, and then we want a 1 for the y. And then the z can be any number, and then the constant can be any number. Okay, now in the third row, we want to get rid of the x and the y terms. So in for x, I'm going to have a 0, but I'm also going to have a 0 in for y. That means I want to just have 1z, and that would be equal to a number. Okay, so, yeah, and this is a number symbol, not hashtag. Okay, so what this means is in the top row, you'd have x plus some coefficient of y. We'll just use a different one. So ay plus BZ equals C. Okay, where those are any numbers. Okay, so you'd have some form of that. In your second row, you'd have Y plus some number in front of Z equals some constant number. Okay, and then for the last one, you would just have Z equals some number. Okay, so this is where A, B, C, D, E, and F are constants. Okay, so if we get Z is equal to a number, then we can use back substitution to solve for Y, then we can use back substitution to solve for X. Okay, so this translates to this, okay, or some number. All right, so our first step, besides putting this in an augmented matrix, is always going to be to get a 1 in the upper left-hand corner, right? It's always this 1 that you want to get first. So our first step should always be to get a 1 in the upper left-hand corner. Okay, so it's always this 1 that you're going to get first. Okay, now the order that you're going to get this in is first you're going to get the 1, then you're going to end up getting the 0 and the 0. So you would get this 1, then the 0, then the 0, then this 1, then the 0, and then this 1. Okay, so they're really just going to go in order from the columns. So you want to obtain the 1, then the 2 zeros, obtain the 1, then the 0, and then obtain the 1. Okay, and we'll write that out as we go. So for our example, we're going to solve the system of linear equations. First, we're going to put this in the augmented matrix. So this is 1, negative 1, 3, 4. 1, 2, negative 2, 10. And 3, negative 1, 5, 14. Okay, so your first step is always to get a 1 in the upper left hand corner. Now, do we already have that?
Yes.
Yep. Yay. Okay, so I'm just going to write my augmented matrix here. Bless you. Okay, and then after that, your next goal is going to be to obtain zeros under the 1 in the left-hand column, or the left column. Okay, so the first one we're going to work on is the one in row 2, column 1. Okay, so let's think about how we can use our elementary row operations to get a 0 underneath the 1. Do you guys already have some thoughts? So So we have to cancel out this 1. Yeah, Dylan?
Multiply the top equation by -1.
Okay,
and
yep.
Add them together.
Okay, so you can multiply the top equation by -1 and then add those 2 rows together. You could also do what? Can you also multiply the second row by -1 and then add them together? Yeah, aren't they both going to work? Okay, so you can choose which one of those you want to do. Okay, so you can multiply row 1 by -1, and then you can add that to row 2, and then that result will go in row 2. So since I'm only changing row 2, the first thing I do is I just put in my other columns because I know I'm not changing those. So if I multiply -1 by -1 and then add it to 1, what do I get? 0. You guys have to be with me here, okay? So for this one, I'm going to be multiplying -1 by -1, which is what? 1. 1 plus 2? 3. Good. Okay, so moving on to this one, -1 times 3. -3. -3 plus -2? -5. Okay, for the last one, -1 times 4. -4 plus 10 is 6. Okay, so now I have the 0 here. I need to get this to be a 0. Okay, so think about what you want to do and how you're going to get there. Okay, and write that on your arrow. Okay, so Eddie, what did you decide?
Multiply row 1 by -3 and add it to row 3.
Good, so multiply row 1 by -3, add it to row 3, and that's going to go in for row 3. Okay, so double check your notation there. So if I'm replacing row 3, what that means is I'm keeping the first 2 rows the same, and I'll write that in first. Okay, so if I multiply 1 by -3 and add it to 3, I get 0. What's -3 times -1? 3. 3 plus -1? 2. Here I'd have what when I multiply? -9 plus 5. -4. When I multiply, I have -12. -12 plus 14 is 2. Okay, good. We did it. We obtained zeros under the 1 in the left-hand column. Now what we're going to do is obtain a 1. So in the upper left-hand corner is the first row and the first column. Now what we're going to do is obtain a 1 in the second row and the second column. Now, the reason why we're doing it in this order is because you'll kind of see as you play around with these, sometimes when you do an operation, it undoes a step you've already done. So if you do it in this order, it eliminates having to go back and rework some of those numbers. Okay, so let's think about how we can get this so that I have a 1 in this position. Okay, so this 3 needs to become a 1. How can I do that? Good, okay, so the most efficient way is going to be to multiply by what? What can I multiply by that's going to make this 1? 1/3, which is the what? Reciprocal. So you can always multiply by the reciprocal, and you'd be able to get 1. Are there other ways you could get 1? Yeah.
I multiplied row 3 by -1 and then added it to row 2.
Okay, good. So you can multiply row 3 by -1, and then you could add it to row 2. Okay, and that'll help you avoid fractions. Sometimes they're unavoidable. We'll find that out as we go. But the reason why that works is because you have a 0 here. So when you multiply and add it to 0, you still have 0. That's also why you could not multiply the first row by 2 and add it. Because if you multiply the first row by 2 and add it to this row, you get a 1 here. But what do you get in the first entry? You get a 2, right? Okay, and that would undo the work that you've already done. That's why you have to be careful. Okay? So you can either multiply this row by a negative and add it here, or you can also multiply by the reciprocal. That's what I'm going to do. So I'm just going to multiply the second row by 1/3. Which means my first row stays the same, and my second row stays the same. So 0 times anything is 0. Multiply by the reciprocal will give you 1. Here I'll have -5/3. 6 divided by 3 is 2. Okay, now once you do that, your next step, you guys probably already know this, is you have to obtain a 0 under the 1 in row 2, column 2. Okay, so that 1 that we just transformed here, we now have to get a 0 underneath it. Okay, so I'm going to want to leave my first row the same and my second row the same because I want that 0 in the third row. What can I do to make this a 0? You said?
You can multiply the second row by -2 and then add it to row 3.
Good. So multiply the second row by -2. Add that result to row 3, and then put the result in row 3. Again, you wouldn't want to multiply the top by 2 because then you would undo this 0. So you're going to find out once you get that 1, you're going to want to use it to cancel things out. Okay, so if you multiply 0 by -2, add it to 0, you get 0. If you multiply -2 by 1 and add it to 2, you get 0. Now, when you're multiplying this, like when I have fractions, this is another no calculator section, so I'll just write my work below. So what's -2 times -5/3? 10/3. Okay, and then I have to add that to row 3, which is -4. And negative 4 as a fraction is going to be what over 3? 12. Okay, so 10 minus 12 is negative 2 over 3. So this will be negative 2/3. And then 2 times negative 2 is negative 4. Negative 4 plus 2 is negative 2. Yeah.
Okay, wait. It's 10 over 3 minus 4. Wouldn't that be 6 over 3?
You have to turn 4 into a fraction.
Yeah, you have to get a common denominator before you can subtract. Because the 4 is like over, the 4 is over 1. So then, yeah, so then I just multiplied by 3 by 3 so I could subtract them.
Oh, I'm sorry.
Yeah, that's
That
okay.
is theoretical.
Okay, and then,
I thought that
yeah, I know, there's a lot going on.
for a second.
Yeah, yep, you just have to get your common denominator, and then your last step is to obtain what? Where? Good, so obtain a 1 in row 3, column 3. Notice whenever you're obtaining a 1, where the 1s are going to go. So this one was in row 1, column 1. The next one was in what?
Row 3, column.
No.
Row 2,
Row 2, column 2, and this was
row 3,
row 3, column 3. So 1, 1, 2, 2, 3, 3. Right? And then, again, a very simple way to obtain a 1 is to multiply by what? The reciprocal. Okay, so again, I'm dealing with row 3, so that means my first 2 rows are going to stay the same. Okay, so Jackson, what am I going to multiply by to get a 1 here? Well, remember it's the reciprocal. So what's your reciprocal?
0, 2.
Okay, so it would be negative 3 over 2. So you're going to do negative 3 over 2 times row 3. And this is nice because whenever you're multiplying by 0, you're going to get 0. The reason why we chose this is so this would be 1. And then this is nice too because negative 2 times negative 3 is what? Negative 6. Negative 6 divided by 2 is negative 3. So you're going to have to remember your fraction rules, right? When you're multiplying a whole number by the fraction, you multiply whole number by the top, divide by the bottom. Okay, so now what we have is a triangular system. What does this mean here at the bottom? Good, z equals negative 3. Okay, that's what that means. So we now have a triangular system. And can use back substitution. Yes.
When you're going from step 4 to step 5, you're multiplying negative 2 by negative 3 over 2. How do you get negative 3? You're multiplying 2 negatives together.
So you said from step 4 to step 5 here?
Yeah, when you're multiplying row 3, column 4.
Oh, when I put negative. Yes, thank you. Thank you.
Wouldn't it be 7 over 2? Or would it be 3?
Negative 2 times negative 3 is going to be 6. 6 divided by 2 will be 3, so your z value is going to be 3. And then, tell me what else you said? That's it? Okay. Yes, thank you. Yep, so you have the negative times the negative, which will be a positive. Okay, and then so your last step is going to be to use back substitution to solve. So let's write out what this system is. So our system, if we have 1, negative 1, 3, 4, do you guys think you can write out what that equation is?
Yes.
Okay, Kaden, can you tell me what my equation is? The first one?
Me?
Yeah.
X minus y plus 3z equals 4.
Good. Okay, and then Logan, what's my second equation?
Y minus 5 thirds z equals 2.
Good. Okay, and then Cam, what's my last equation?
Is it just Z?
Yep, and that's going to be equal to?
3?
Good. Okay, so then when we're using our back substitution, we already have our z is equal to 3. So then I'm going to do y minus 5 thirds times 3 equals 2. And this is nice because 5 thirds times 3 is going to be what? 5. So it would be minus 5 equals 2. So then I'm going to add 5 to both sides to get 7. And then I'm going to have x minus 7 plus 3 times 3 equals 4. So this is going to be 9. Negative 7 plus 9 is 2. So if I subtract 2 from both sides, I'll get x equals 2. And then the nice thing about this is you know whether or not your answer is correct, because what can you do? Yeah, you can check by plugging in values into the original equations. Okay, so then let's check that. So if you plug in 2 for x, you have 2 minus 7, which is negative 5. Negative 5 plus 9, is that going to be 4? Yep. Okay, so if I plug in my values here, I'm going to have 2 plus what? 14, which is 16. 16 minus 6, which is 10. Good. And then 3 times 2 is going to be 6. 6 minus 7 is negative 1. And then it's negative 1 plus 15, which is 14. So, yep, all 3 of these checked out. So you know that your answer is correct. Okay? All right, I'm going to give you some time to start your homework today. Some of your first questions are just about the terminology that we've learned today, because that's a little bit new. Okay, so like numbers 1 through 10 and 11 through 14 are going to be a lot of just terms and being able to figure out what a matrix is and an augmented matrix. For 11 through 14, you're going to do parts A through C, but then for 15 and 18, or 15 through 18, you're going to do A and B only. All right, and then you're going to do 19, 20, 29, 31. Okay, and then I'll put your book up so you can